Welcome to CZ4034 project presentation. This is the outline of our presentation. Firstly, introduction. Our group members are Cao Gaoxu, Chen Ziao, Liu Peng, and Pan Jiangdong. This is a summary of works done by each group member. Nowadays, people like reading news posted by famous news channels on Twitter. However, different people have different preferences on different news. For example, some people may prefer reading political news, others may prefer reading business news. So the objectives of our project is to build a web application that gets news from different news channels on Twitter and classify the tweets into certain categories so that people can search for news they are interested in very easily. Right side will be the software and frameworks we have used in our project. The web applications is built in under Django framework, and Twippy module is used to connect our application with Twitter API, and sklearn packages is used to perform classifications on tweets. Indexing and currying are achieved using solid built-in functions. For crawling, we first crawl JSON format data from Twitter API. The screenshot here shows the raw JSON data of one tweet retrieved from Twitter. Since we do not need all fields, we perform some basic preprocessing to retrieve certain columns we need. These are tweet data stored in Solr. Each tweet will just have a few columns such as content and name of news resource, number of likes, and number of retweets. For indexing, since Solr provides a lot of powerful functions, we decide to use Solr to perform indexing. Indexing is performed actually on the content of each tweet. Functions used are removing stop words, lowercase letters, and stemming, and also n-gram filters, and some other functions. This is our web application. In the middle, we can see a lot of tweets retrieved. On the left side, the user select different categories of news, such as business, political, social, technology, and other news. Besides that, the user can also read news from different news channels such as CNN, BBC World, Straits Times, New York Times, and Wall Street Journal. In addition, user can also click on the right side drop-down box to sort the tweets retrieved. We can sort by time, sort by popularity, and sort by number of retweets. Lastly, user can choose to update tweets to get the most current tweeters from news channels. User can choose to update the news from one or multiple channels, or just update all. For example, we can see that for BBC World News, the newest news in our system is on April 7th. When we click on Update, after a few seconds, the BBC World News is updated to be April 8th. User can also search news based on keywords. For example, user input Donald Trump and press enter. System will retrieve news about Donald Trump for him. If user misspelled the Donald Trump, the system will provide a suggestion on the misspelled word. A user may just click on it to correct his search input. For classification, we perform some pre-processing steps on the text before classification, such as removing stop words and stemming. All text will be converted into a document term matrix, and we have also used the TF-IDF conversion to give each document a relevant score. The TF-IDF matrix is used to build a model. We have tried different models to see which one gives the best performance, and we have found out that linear support vector classification model gives the highest accuracy, recall F measure, and also the second highest precision. So we decided to use it as our final model. However, when we manually label the data, we find out that there are around 46% of tweets are political news, hence there are potential sampling problem due to too many political news. So we use undersampling techniques, and based on the statistics, metrics in yellow are all those improved by undersampling, and overall undersampling seems to improve our model. There is also a potential overfitting issue. Our model may fit the training data, but not the new tweets from Twitter. Therefore, we perform 10-fold cross-validation on each model to see which model is truly useful. And based on the result, linear support vector machine classification model still has the highest cross-validation score, which again further justify our choice on it as our final model. And that is all for our presentation. Thank you for listening. We hope you enjoy our presentation.